So the daily problem today is evaluate reverse Polish notation, which is like a calculator problem, but with a specific notation. So the idea is we have this equation and we have to give the integer solution rounding towards 0, and we never have to worry about dividing by 0 or anything. So here we have 2, 1 plus 3 times. And the idea of reverse Polish notation is just that the operator is at the end instead of in the middle. So 2, 1 plus means 2 plus 1. And then 3 times means that times 3, which we can see here with use of parentheses. So here we have 4, 13, 5 over plus. So what this means is 4 plus 13 over 5. And an interesting thing about this problem is it's one of the few problems in my mind where iteration and recursion are both possible, and recursion is a lot more complicated than iteration is. Usually with something like backtracking or something like that, recursion is a little bit easier to make sense of, and then in a job interview setting they say, well, can you do it iteratively? And then it's slightly more confusing, but typically in code bases, iteration is preferred over recursion because it doesn't really mess with the call stack as much. But here we can use iteration very easily. So the way we can sort of think about this is you start with a number, you add another number to the stack, you keep going until you get to a plus where you know that what's going to happen is it's going to be the last number on the stack plus the previous number on the stack. And in a situation like this, where you have a bunch of numbers on the stack, you'd add these 3, you say over. Okay, well, we know that that's 13 over 5. So then 13 over 5 is going to be 2 because we're truncating towards 0. So then we say, okay, we'll add that to the stack. So now instead of the stack being 4, 13, 5, the stack is going to be 4, 2, this new evaluation of these. Of these 3 elements and tokens. And then we say, okay, 4, 2 plus is 6. So that's sort of our way of really easily simulating parentheses by using a stack. And then once we think about that, it's actually pretty easy to just type out. So we say stack is dq for I in tokens. So for each element, we say if I dot is digit, then stack dot append I. And we also have to account for negative numbers. Like here, negative 11, if we said if I dot is digit, it would say, no, this must be an operator, but it's not, it's negative 11. So how do we get around that? Because minus is also a character we use for the operator. It's actually pretty simple. We just say if I dot is digit or length of I is greater than 1, because we know that all the operators plus, minus, times, over have a length of 1. So then append it, and that's all we have to do there. And we can even just say continue here, so we don't really need an else statement. And then we want to say, all right, well, if we know that that's not true, then we know it's plus, minus, times, or over. So in that situation, we say if I is plus, if I is minus, we'll do else if I is times. And we could say else if I is over, but we know that it will be because this is the only 4 options. So if I is plus, we can say something like x, y is stack.pop, and then we say stack.append x plus y. And actually, if we go through here, we would say x, y, stack.pop, append x minus y. So we can actually just put this here because we know that we're going to do that for all of them. So then here we just say stack.append x minus y, stack.append x times y. And here we could say something like stack.append x over y with 2 slashes, which means integer division. But the problem with this is that this always rounds down, which is very close to what we want. But if we said 4 over 3, that would give us 0 or 1, which is what we want because 4/3 rounds down to 1. But if we said 4 over negative 3, then that would give us negative 2 because it would say, oh, well, that's negative 4/3. So negative 1.3 repeating, that rounds down to negative 2. So we could say something like, if x is less than 0, XOR if y is less than 0, something, and figure out some way to know if the finished product is going to be negative. Or we could just say int of x over y. This is a nice little Python trick. And this will round, this is the same thing, but it rounds towards 0. So when it's above 0, it rounds down. When it's below 0, it rounds up. And actually casting to int, here we're casting x over y, which would be a float or a double, I forget. We're casting that to an int. We actually have to remember that tokens is a list of strings. So we don't really actually want to append I in each situation. We want to append int I. So this will say, hey, 3, we don't want the string 3, we want the number 3. Negative 11, we want the number negative 11. So then what'll happen now is it'll populate the stack with 2, 1, okay, evaluate that to 3, and then multiply that by 3, evaluate that to 9. So in that situation, when we stack.append 3 times 3 is 9, what we're going to wind up with in the end, we always will wind up with a stack with exactly 1 element, which is our final element. If we had more elements, that would mean that this was some weird, disjointed set of multiple terms, which I think part of the conceit of the problem is that that won't happen. So we just say return stack.pop. And this is almost done, but there's actually one more thing we need to do, which is to say, hey, this is a stack. So we add 2 to the stack, we add 1 to the stack. Let's actually look at a problem like this. We add 4 to the stack, we add 13 to the stack, we add 5 to the stack. And then we say over. Okay, well, x is stack.pop is 5, y is stack.pop is 13, and then, oh, well, what's x over y? The problem is here, this is saying that's 5 over 13, because we peeled the stack backwards. So really, what we actually finally want to do, you could do this at any point, but it's worth pointing out as its own sort of interesting phenomenon, because a stack sort of has this depth first search quality of reversing the order of the elements when you pop them. We want to actually have y and x be reversed, if that makes sense. So here we're saying actually pop y off first because that's the most recent one. So specifically with subtraction and division, where we can't really just use x and y interchangeably on either side of that operator, make sure that the order's right. So now when we run this, yeah, it should just work. Cool, and you can see, I would imagine, I think these 2 humps, this is more people doing this sort of iterative solution with a stack, or in Python, you can literally just use a list as a stack. And then I would imagine these are some sort of more inefficient, potentially recursive, yeah, this person defined their own function. And this is actually my first impulse, but as it turns out, this gets kind of complicated, and you potentially need to keep track of the index that you're at through recursion, which is a little bit of a nightmare. Whereas this is very elegant as well as very quick. So that's the daily solution.